So let's start by understanding the basics. So in other words, we're going to do a quick lesson before today's actual lesson, okay? Let's start out by understanding multiplication. Now we already know how to multiply integers, like -3 times +2 is -6. But let's take a look at multiplying variables. What if I said x times x? Well, x times x, there really is nothing to do. The only thing you could actually do there is write it as x squared, okay? Now let's say we did have x squared and then times x to the third. This is actually the first lesson of exponents, or the first rule of exponents, that when you have the same base, you could add exponents, okay? So for example, x squared, this x squared right here is really x times x, and this x to the third is really x times x times x. And we, of course, we are multiplying between the two, so it's really x times x times x times x times x, which is a total of x to the fifth. So we could multiply x's with x's. All you got to do is add the exponents. I want you guys to think about this right here. X to the fourth times x to the fifth. It's not x to the 20th. What's the answer? X to the 9th, okay? So we got that little lesson down, or that understanding. When you're multiplying two terms with the same base, you simply add the exponents. Now what if you actually had numbers in front of these variables? Let's start out with something basic, no exponents. 2x times 3x. The way to do this is to really recognize that the 2x really means 2 times x, and then you have times 3 and then times x. So it's all multiplication, and if you have pure multiplication, you could actually switch the order. It's called commutative property. You could switch the order and you still get the same outcome. In other words, 2 times 3 is the same thing as 3 times 2. They're both equal to 6. So in this case, I'm actually going to multiply. I'm going to rewrite everything. I'm going to take this 2 and this 3, and since it's all pure multiplication, I'm going to write down the 2 times 3 right next to each other. And then I'm going to write down this x times this x right next to each other, times x times x. And now we could actually multiply 2 times 3, and we'll get a final answer of 6 right here. And x times x, that's the final answer of x squared. So the original 2x times 3x, the original answer is 6x squared. So I hope you guys understand that part right there. Let me do another one. How about this guy? We have 3x squared times 2x to the third. Now remember, it is all pure multiplication. There's 3 times x squared times 2 times x to the third. So you could switch things around. What I'm going to do is write the 3 times 2 first, and then I'm going to write down the x squared times x to the third next. And of course, we're going to do the 3 times 2, that's 6. And then x squared times x to the third, we add the exponents, and we're going to get x to the fifth. So this original problem, 3x squared times 2x to the third, 6x to the fifth is our answer. Let's try one more, but let's throw a twist in it. How about 3x to the second times 2y to the third? Okay, it is true that we are multiplying all the way through. 3 times x squared times 2 times y to the third. So you could rearrange things. Let me put the 3 right there times 2 right there. And let me bring down the x squared times y to the third. So you can do 3 times 2. That'll give you 6. But the problem is x squared times y to the third, you cannot combine those exponents. Right there you have different bases. So you really can't do anything except bring them down. So you have x squared times y to the third. And of course, you don't need to put these multiplication signs. So you could just leave it without those multiplication signs. And that's your final answer right there, guys. 6x squared y to the third, okay? Last one before we move on to the actual lesson of today. So right here we have 4a times 3b times 2a to the third, and of course it all has multiplication between each and every term, only multiplication. Okay, so we could rearrange everything, and let's put the 4, the 3, and the 2, those are called coefficients. Let's put all those coefficients together. So you're going to have 4 times 3 times 2, and then let me bring down everything else. Now I have an a right here, a b right there, and an a to the third right there. So I might as well arrange it nicely, and let me put this a with this a to the third. So we have times a to the third, and then we, at last but not least, have this b that I'm going to write down at the very end. Okay, so what is 4 times 3? That's 12. And then 12 times 2 is 24. And then let's go for the a's. Right here you have a times a to the third. That's actually a to the fourth. Why? Because there's really an invisible exponent of 1, and the rule that we're using is when you have the same base, you could actually add the exponents and get a to the fourth. And last but not least, bring down that b. So there is your answer, 24 a to the fourth b. So I guess what I'm trying to get at here is you could multiply any term with any other term. Even if you can't actually combine, like the a to the fourth times b, you can't really combine the exponents there, but you just leave it like that, and you do get an answer. So anyways, actually, you know, there's one more that I would like to discuss with you that's so easy that some people get confused. How about something as easy as 2 times x? Could you actually do 2 times x? I mean, yeah, the answer's 2x. Now, what do I mean by that? Because what is actually between 2 and x? There's nothing, which means it's multiplication. So 2 times x is really 2x. I know it sounds kind of silly, but I do want to state that because in today's actual lesson, we will be faced with something like 2 plus x, and you cannot combine numbers with letters. You can't really add 2 plus x. 2 plus x is exactly that, 2 plus x. Write that down, plus x. Or of course you could switch it whenever you're adding, just like pure multiplication, there's commutative property in multiplication, you could switch the order. Right here you could also switch the order and write it as x plus 2. So I just want to make that point clear. You could multiply numbers and letters, but you cannot combine numbers and letters. Okay? We'll see that on today's lesson. So let's move on to today's lesson. All right, guys, so right here we are gonna cover distributive property and combining like terms, and this is section 1.4 of our class, 1.4. So this is the final section that's gonna be on the test Friday. So let's talk about distributive property first. In order to really understand distributive property, it would be a good idea to understand what distribution means in general. So for example, if I told you that I wanted to distribute this piece of paper, let me show you. Okay, so I have 4 students here, 1, 2, 3, 4, and I have this piece of paper or a stack of papers that I want to distribute to each of the students. So let me actually demonstrate this. I'm going to distribute this piece of paper. I want to distribute it to him, to her, and to her. So let me show you how that's actually going to work. I'm going to distribute it. There it is, 1 to him. There it is, 1 to her. There it is, 1 to her. And there it is, 1 to her. Sorry, so they all have my paper. And of course, they got my thumb also. I chopped it off right there. Anyway, that's what distribution really is. What we did was I distributed my piece of paper to each one of these students. So that is exactly what distribution is, but we have numbers and variables. So for example, if I had a 3 on the outside and maybe a plus 2b minus 5, let's say, then we could distribute the 3, kind of like I distributed the paper up here to each of the students. I'm going to distribute that 3 to each term on the inside. And I would get 3 times a, that's 3a, 3 times 2b, that's 6b, and 3 times negative 5, that's negative 15. And that would be my answer to that distribution of 3. And that's exactly what distributive property is. It's simply distributing the multiplication of a certain term on the outside to each and every term on the inside. Kind of like if you're distributing a piece of paper. You're distributing that piece of paper to each and every person. It's the same thing, distributing the multiplication of the outside term to each and every term on the inside. So let's go to the actual notes that we handed out today. Once again, distributive property is simply to distribute the multiplication of a term from the outside of the parentheses to the inside of the parentheses, right? So number one, let's distribute 3 times x, that's 3x. Remember, we can multiply numbers and letters. 3 times 2, that's 6, and of course there's a plus sign between it. That's your final answer on number 1. Jumping to number 3, skipping around, that is, we're going to take this minus 5 and distribute it to each of those terms. So negative 5 times 2x, remember, negative 5 times 2, that's negative 10, and then you just bring down the x right there, because you can multiply numbers with letters, right? And how about negative 5 times negative 4? Negative 5 times negative 4, if you call that a negative, that's going to be a positive 20. Ladies and gentlemen, that is your answer for the distribution problem on number 3. Let's jump around and do number 5. Yeah, if you might have a minus sign, that might be so easy you get confused. Or it is so easy you might get confused. Negative, distribute it to the x, that'll be a negative x. Distribute it to the negative 7. Negative, negative changes the plus, plus. That's your answer right there. And we might as well jump back and do number 4. We're on a roll here. Let's distribute negative 2 times negative x. A negative times a negative is a positive. Or you could even visualize a 1 right there, an invisible 1, and think negative 2 times negative 1, that's positive 2, and the x just comes down with it. Negative 2 times positive 1, that would be a negative 2, and that's your answer for number 4. So I think we understand how to distribute the multiplication of a term that's on the outside to the inside. Now let's go for combining like terms, the next part of this lesson. What does combining like terms mean? It means to combine the terms that look alike. X's with x's, x squares with x squares, y's with y's, numbers with numbers, apples with apples, oranges with oranges, etc. So let's demonstrate here combining like terms. I have 2 markers plus 1 more marker. What's that going to give me? A total answer, 3 markers. And the above space right there, you'll have 3m. But let's switch it up. How about this? Let's say we have 2 markers plus 1 eraser. Okay, so if I have 2 markers plus 1 eraser, what do I have? It's not 3 markacers. You can't do that, right? It's just, that'd be wrong. It's actually just 2 markers and 1 eraser. So the answer to 2m plus 1e, 2 markers plus 1 eraser, is exactly that, 2 markers and 1 eraser. You can't really do it, just rewrite it. So the answer would be exactly that, 2m plus 1e. So back to these examples right here of combining like terms. Example number 1, what could we combine the terms that are alike? X's with x's, numbers with numbers. So I like to circle and box in and underline whatever I'm combining. And it's very important to include the sign that's in front. So right here I have 3 x's, and then I take away 7 x's. It's just like thinking of money, right? We're adding and subtracting, we're thinking of money. I have $3, but I owe somebody $7. I can't even pay them off. I still owe them $4, but in this case it's 4 x's, okay? And those are the only terms that are alike. Those are the only terms that I could combine. What about the plus 2? I need to bring it down. There's my final answer for combining like terms on number 1. Moving on to number 2. Again, we could combine x's with x's. So I'm circling it. I'm including the sign that's in front. That's positive 2x. That's negative 9x. Okay? Again, we're combining, right? It's like adding and subtracting. Again, we're thinking of money when we add and subtract. So it's like you have $2, but you owe $9. You can't even pay them off. You're still going to owe $7, but in this case, 7 x's. And what about this minus 3 and this plus 8? Again, it's very important that you include the signs that are in front of these numbers to think of as you have or as you owe. So anyways, you owe $3, you have $8. Yeah, you're going to be able to pay them off. You're actually going to have $5 left over, and that's your answer for combining those like terms on number 2. Unfortunately, we are out of time. I'm going to do a second video picking up on number 3 right here.